Okay, in this video I would like to demonstrate, or not demonstrate, I would like to discuss about the parity generator and the parity checker, because in my previous slide I exclude the parity generator, but if I see in the upcoming lab there will be the topic about the parity generator and parity checker, so that's why I add the supplementary supplementary slides here. So let's see what is the parity generator and parity checker. A parity generator is a combinational, another example of combinational logic circuit that generates the parity bit in the transmitter. So the parity here means the error generator or the error checker. Okay, a parity bit is used for the purpose of detecting errors during a transmission of the binary information, and it is an extra bit included with a binary message to make the number of ones either odd or even. A parity bit can be added either in the beginning or at the end of the bit number. So for example, you have the number of bit here. So for example, A's number, okay, number A, and then need to be transmit. TX is a transmitter, so to transmit to system number to the TX. So the parity checker is the simple technology to check whether during this transmission is there any error or not. Okay, so it's basically the simple technology to detect the error. Alright, so next slide. There are two types of parity. First one is the even parity, and then the second one is the odd parity. So in this example, the parity bit is added at the end of the bits number. So you also can have this parity bit at the beginning of the number. Okay, so what is even parity? It is the added parity bit, extra bit, or we call it as the parity bit, which will make the total number of one an even amount. And for the odd parity, the added parity bit will make the total number of ones an odd amount. Okay, so let's see. For this data frame, we have 1001101. So how many one in this data frame? 1, 2, 3, 4. So to make it an even parity bit, so the even numbers of 1 must be seen in this data frame. So we have here 1, 2, 3, 4. So in order to have the even parity, so you need to add the 0. Okay, so kalau you add 0, the number of 1 still even, which is 4. Okay, so for the odd parity bit, the original from the original data frame, the numbers of 1 are 1, 2, 3, 4. Okay, so in order to make it the odd parity bit, you need to add 1. Okay, so now the numbers of 1, okay, this is numbers of 1 is from 4 to 5. So 5 is an even number, so it is the odd parity bit, right? And the parity checker is the circuit that can check the parity or can check the error in the receiver, so that we call it as the parity checker. And the parity checker circuit check for any possible errors in the transmission. Since the information transmit with even parity, like I said before, the receiver must have an even number of 1. So if it has an odd number of 1, it is indicate there is an error occurred during the transmission. Okay, let's see alright, so okay, let's see how about the odd parity. The output of the parity checker is denoted by PEC, which is parity error checker. If there is an error, if it has odd number of 1, it will indicate 1. So if no, then the PC will indicate 0. So for example, like I said here, okay, the previous for example, the data transmit is 101011. Okay, so now we have, this is the original bit. Okay, original bit number. So we want to add, we want to check using the even parity. So the even parity, we know that it must have the even number of 1. Okay, so by adding 0 to this bit, to this original bit, so let's add 0 here, which is the parity bit. Okay, so the total number of 1 still even. Okay, 1 2 3 4, 4 ones. Okay, and for example, during the transmission, okay, this is Rx and this is the Tx. During the transmission, the number will be 0 0 1 1 0 with this the extra bit. Okay, okay, now we know that this number, or this will cause the error, because now the number of 1 become odd. 1 2 3 4 5, even we check using the parity checker. So we can trigger the PEC will indicate as high. Okay, will indicate as 1, because now the number of 1 here is odd instead of even. Okay, what else? All right, so let's see another example. Suppose that a sender wants to send the data 1001101 using the even parity check method. Okay, in the question, the question will mention which parity checker that you need to use, either even or odd. So it will add the parity bit as shown below. So this is the original data that need to be transferred, 1001101 with how many 1 here? Let's count 1 2 3 4. So it's already an even number of 1 here. Okay, so using the even parity bit, you need to add 0, because the number of 1 still need to to maintain with 4 with even number of 1s. All right, so okay, this is the solution. Okay, the receiver will decide whether an error has occurred by counting whether the total number is even or not. So because in the question they already mentioned using the even parity checker, so the number of 1 must be an even number. Okay, when the above frame is received, so this is number that want to be transmit. 3 cases may occur, namely no error, single bit error detection, or failure detect multiple bits error as illustrated below. So for example, you have 1 2 3 4 4 number of 1 which is even. So if the transmitted number is now become 100111110, so the number of 1 here is 5. Okay, so there are extra 1 here which is we don't know, that's called the error. So now the number of 1 become 5, which is not even anymore. So the PEC will detect the error. The parity error check will become 1. Okay, so for case number 3, 10011010, so the parity bit is now 0, so there is no error detected. Okay, that's all for parity checker. Thank you very much.